Welcome to Iceblue-REM and CSS variable presentation. I'm Matt. If you've not seen me on previous presentation, I am a support engineer and consulting engineer for ZK framework. You may have interacted with me on tickets before or through the forum. We're going to talk about the theme customization with modern tools in ZK today. As a quick note, before we get into the meat of the topic, as usual, the presentation, the slides, the code sample, and the recording of this meeting will all be provided after the meeting has concluded. So you don't need to actively take note. Just let me know. We will send you an update when those materials are updated. Regarding questions, feel free to ask questions as we go if you'd like any additional information on what I'm talking about. If the question is relevant or short, I'll be answering them as we go along. If it's a longer question or if it's slightly out of topic, we will have a Q&A session at the end. So in any case, just put your questions in chat and we will address them during or after the session has concluded. Okay, without further ado, let's go and start the presentation. So, introduction. What are we going to talk about today? We're going to talk about REM units, what they are, how they are used in a modern page styling context, as well as CSS variable and their use as well. Then we're going to go into how they can be used in a ZK page, which is most of the same compared to a normal page. And lastly, we're going to talk about some exciting new development in ZK theming, which is the Iceblue-REM theme, a new version derived from Iceblue, and the benefit it has when using those new tools. Okay, so let's start with REM units. If you have done any sort of front-end development, you're probably already familiar with this. We're going to go through the basics first, and then we're going to go into how they apply. REM units are relative units that are relative to the page root element. So that's the HTML tag in your average web page. And that are relative to the font size that is declared on that element. The use cases for this type of unit very simply are accessibility. Some of your users may have different needs in terms of font size display for the device. They might have a high resolution device where a larger font size is necessary in order to still be able to look at the content in a comfortable way. They might have vision issues that requires them to use larger units for the fonts and other graphical elements on your page. Or it might simply be a preference. Some people like to have more information on screen. Some people like the information to be slightly larger to be more comfortable to read. REM are used as units instead of pixel or instead of EM units, if you're familiar with any of those. And broadly speaking, an REM unit is going to translate into a pixel unit that is derived from the root element's font size. As for CSS variable, if you've done any development and considering that you're currently joining a training session on a development framework, I assume that you're familiar with the concept of variables. A CSS variable is exactly what it says on the tin. It's simply a variable that you declare and that you reuse in different places of your CSS code. They are useful to quickly separate your palette, which is to say the individual choices that you make between different variations on a theme, and the style sheet and layout of the page, which generally are consistent between variations on a theme. They're also useful because you can declare your variable once and then reuse it in multiple places. That's exactly how a variable works. And they're easy to update. You just change one value where you declare your root variables, and then any changes that you make here are applied in turn to everywhere that variable is used. Okay, let's get to the basics. I've already talked a little bit about it, but a REM unit is a root EM unit. It's based on the font size of the HTML tag of your page. By default, most browser will give a font size of 16 pixel. So by default, a one REM declaration is equal to 16 pixel. And then you simply multiply it. 2 REM is going to be 2 times 16. That's going to be 32 pixel. 0.5 REM is going to be 8 pixel. In ZK, the root font size used to be 8 pixel. So 1 REM by default is 8 pixel. But in Iceblue-REM, we have a little bit of extra utility there to configure this. When should you use this? Pixel units, you're familiar with those. They are fixed units. They're very suitable for static elements, for borders, for things that generally should stay the same for the customer experience, regardless of the size at which the user view your page. The EM variables, which are slightly out of scope for today, are locally relative. That means that instead of being relative to the parent element, sorry, the root element of the page, they're relative to the direct parent of the object that consumes that variable. They're useful for making a block in your UI that scale with itself, but not necessarily with the rest of the page. As I mentioned, a bit out of scope for today, so we're going to focus mostly on pixel and REM. Lastly, REM, as I mentioned, is globally predictable. It ensures that your component size stays relatively scaled compared to each other and compared to your page globally. It also scales with user settings. If your user have a need to change the resolution of your page, that ensures that the resolution of the page scales in a predictable and in a controllable way. All right. And CSS variable, as I mentioned, it's a variable that you use in CSS. You declare it either on your root element. Because it is a CSS variable, it is subject to all of the cascading rules that CSS normally use. You can redefine it by declaring another CSS property with the same name and just have it override the one that is inherited from the ancestors. And anything else that you can do with a CSS rule, you can do with a CSS variable. You can consume it with the var CSS function. The var CSS function very simply lets you target a variable that is in the current namespace and apply that value directly to your style sheet. So I'm staying as short as I can on the basics. But we're going to get into some example, make sure that you can see how that works in a real page and how that can be useful. I've included a little bit more information. That's going to be for people who want to read the slides for the concept that you may want to look further into. I'm not going into a lot more detail in the code sample with this, so I'm going to quickly mention them. I'm not going to say advanced, but some useful thing to know. A CSS property that contains a CSS variable start with 2-. I realize now that my choice of font for this presentation does not show that there is a gap between the 2-. You can also declare it as an @ rule in the same way that you declare other @ rule in CSS. that lets you provide not just the variable content, that also can let you set some behaviors on the variable, as whether or not it is inherited, whether or not it is controlled or overridden by other variable with the same name. It's a more advanced topic. If you're interested in learning more, I strongly recommend the MDN article on the topic. It's definitely the best resource if it's your first exposure to CSS variable. And lastly, when you consume the CSS variable with the var function, one useful thing you can do is put in the variable name that you want to resolve and add a fallback value. So if your CSS style sheet fails to resolve a variable with that name, you will have a default value provided for that namespace. All right. So let's skip ahead a little bit. That theory is all well and good, but we want to see how that works in a page. So REM unit CSS variable in ZK context. As you may already know, a ZK page is just that. It's a web page. So any tech that you can do with CSS variables in a bog standard HTML, JavaScript, CSS page, you can also do it into as a page that is generated and displayed by ZK. You can use your CSS variable targeting any CSS class. You can do that with ZK built-in class. You can do it with custom classes. So let's take a quick look. In this example, you can see that I'm targeting either the root element of the page or the HTML tag of the page. In this HTML tag, I've defined two variables. That means that those two variables, which start with double dash, are going to be available to the HTML tag and to all of its descendants. In those variables, I can store a value that is then going to be consumed by the CSS class that uses those variables. You can see here that I have a my custom background variable, and the value of that variable is red. And I have a my custom font height, which has value bold. I can target a DOM node using any CSS selector that is valid in any page. And in this case, it's a ZK page. So we have built-in classes. For example, the Z-button is the built-in Z class for the button component. So both of those buttons are holding the Z class Z button. And I can also target elements by other means, like by IDs, by CSS selectors that are more complex. So nested classes, children, pseudo element, all of those works. But we're going to stay simple. For this example, I've created a button that has a S class. An S class is going to be applied to the element generated for that button as an additional class that can be targeted. So I target this class and I apply a rule to it. What rule do we apply? We apply a background rule. Background, in this case, we just apply a background color. In order to retrieve the color, we simply put the var CSS function, indicate which variable we want to resolve, and your browser is going to automatically look up CSS variables in a cascading way up to the root element of the page, is going to find eventually the my custom background variable declaration on the root element, and is going to resolve this as red. Those two lines are essentially the same, except if I have more than one element that consume my variable, I'll be able to have that variable be reused in multiple places or updated from a single line. Okay, so what do we expect to see as a result of this? We have a rules that target Z-button. Both of those elements are Z-button. That's the default button class for ZK. And we have a custom rule here that target only the custom button. If we look at the end result in browser, you can see here exactly what I just explained. Let me open this a little bit bigger so it's easier to see. We have our regular button here, which received the Z button default class from ZK. We have here our background being resolved from the my custom background variable. And you can see on the root element, amongst other variables declared here, that we have our custom variables here available. So what can I do with that? If I have a need to change a setting globally, I can simply edit my variable into what is essentially a palette that lives at the root of my page, and every places that consume that variable gets modified automatically. This is very similar if you've used the ZK theme builder to the concept of palette in the ZK theme builder. The main difference there is the palette in theme builder up to now is compiled from a less file. So it's built at theme compilation time. Whereas the CSS variable approach is just evaluated by the browser at runtime. So you have a lot more flexibility at the cost of extra calculation. Although as long as your page is not gigantic, the calculation cost of CSS variables is fairly easy to manage. That's a bit of an advanced topic, but if you're interested in more on that, we can go on to it in the Q&A at the end. All right, and the same thing for the custom font weight. If I want to have a change on that variable, it will be applied globally to all of the places which consume that value automatically. Okay, I think for those basics, we are good to go. Let me switch back to the presentation. All right. REM sizing in a ZK page. It's more of the same. If you've understood the concept already with the CSS variables, the REM sizing works on a very similar idea. Instead of resolving a size based on a CSS variable, we're going to resolve a size based on a function of the default size of the browser. So how does that look? It is pre-built in ZK10, and you can customize it. Let's go to just a code sample directly and have a look. So here in this case, we have two use cases for REM units. The simplest one, you will find that this is mostly the same screen. Just in this case, we're updating sizes, not colors. The simplest one is to take your default button and to just declare a font size on it, or any other property that is size related. It could be a width, it could be a height, it could be a padding, it could be anything that you can calculate in pixel. In this case, I put a font size equal to REM on my button. In order for this to be useful, I will look up the REM value on my root element. Root element in this case is also HTML. You can use the pseudo class :root in CSS to locate your root element without having to manually find it, which is especially useful for cases where you may have more than one HTML tag in your page, but that's complex case. And if you're in that situation, I'm sure you already know about this type of trick. Okay, so what do? We look up the font size. It's 16 pixel on the root element. We have a font size of 2 REM, so we multiply that value by 2. 16 times 2 is 32. That means that we're going to resolve a font size of 32 pixel, dynamically tied to the font size of the root element. And for a little bit of fun with CSS variables, which we already discussed in the previous section, My second button here, the one named custom button, has a custom button CSS class as well, same as the first time, except here I'm declaring a font size on it, which is resolved by looking up a variable named my custom font size. And my custom font size, as with the previous example, is a variable that I declare on the root element of my page. In this case, it's 3 REM. If you can do quick math, you will already know that it is 3 times 16. So let's see how that behaves in the actual page. By default, you can see here, if I inspect my buttons, that my font size here, if I put my mouse on the text in REM, I'll get a helpful hint to show me the result of the calculation. So 2 REM here are 32 pixel, 3 REM in this one, which is resolved by my custom font size. If I go check my custom font size, is 48. And on my root element, HTML here, if we do make changes to the font size of the page, for example, I'm going to go to 10 pixel as the default font size, I'll then be able to see that the calculation in REM unit is automatically cascading to any element that consume this sizing. So why is this useful? If you want a UI that can quickly change between different sizing and has no major breaks due to changing that sizing, using REM is a great way to make sure that individual sizes used in that layout are not only relative to the root of your document, but also to each other, since they're all relative to the same source of information. Okay, and if I go the other direction, of course, you do understand that all of those things stay relative to each other, regardless of the changes that you may make to your font size. Okay, I know this is very basic. As I said, we're going into the broad stroke first, and then we're going to go in a little bit more into what ZK, let me go back to my presentation, what ZK is providing as new and interesting tools based on those concepts. So a little peek behind the curtain. We're currently working on a variation of the Iceblue theme, which we've named Iceblue-REM. The Iceblue theme you already know about because it is the default theme in ZK since ZK 8, is our current modern theme. That theme has been improved over the years, and our next step, what we are aiming for at the moment, is to include all of that resilience, all of that use of usability and customizability from CSS variable and REM units into Iceblue. As of now, this is an experimental build, which is released under a different package name, Iceblue-REM. We are going to gather some feedback. We're going to continue working on it. It might become the default way that we do sizing in the future, but at the moment, this is still brewing. So if you want to try it out, the current approach will simply be to, if you're using Maven or Gradle, you'll have simply the option to declare the Iceblue-REM package that you can load with your ZK dependencies. And in your zk.xml, to simply use the Iceblue-REM theme instead of the Iceblue theme to have all of those options directly available out of the box. All right. So why do we want out-of-the-box REM support? Generally speaking, we want to simplify customization for our users. You don't have to reinvent the wheel. ZK provides sizing. Just use the size palette, and you'll have sizes that fits at all definition, all zoom level, and that the user can easily control if you give them the option to switch between different font size for their root element. It's packed with utility variables. You can use those variables in the same way that you would use the utility classes for Font Awesome or for Bootstrap's layouts, if that's something you're familiar with. And this is based on the ZK font size variable. We've made the decision to have a unique point of entry, which is exactly the same logic as the font size of the root element, with a little bit extra customizability, so you can control the ratio and a few other parameters there. So it's easy to customize. Let's go to a code sample and I'll show you around directly. I think that's easier. So we have utility classes now in the Iceblue-REM theme, which will let you quickly set an REM value without having to do manual calculation and without having to draw all of those individual REM classes yourself. If you want to use it directly in line style, you can use simply --zk -rem and then the zoom level that you'd like to use. So in this case, the exact same page that we had previously with manual REM definition can be shortened using those variables. This one is targeting a pre-built REM value of 2. This one is packing a pre-built REM value of 3. And they're both modified by the Iceblue-REM ratio. What does that look in practice? We'll go to the application here and take a peek. So as I said, it looks exactly the same as the previous screen, except we are now relying on those variables here, which are built in the Iceblue-REM theme. You can see that we have a whole list of different sizes that are pre-built in. All of those can be referenced directly, and they're all depending on the ZK-REM ratio. The ZK-REM ratio itself is a variable that you can control directly in your style sheet. So if we go back here and we set a ZK-REM ratio of 0.5, for example, and go back to our page, you can see now that with our ratio of 0.5, all of those calculations have now been divided by 2. And that ratio can also be directly controlled into the page itself. If you have JavaScript that updates your page, you can easily change the ratio, change the appearance of your page with that single point of control. All right, let's go back to 1. I'll stay short on that. If you have any questions, we can discuss them at the end. Let's go a little bit further. We have Iceblue-REM and Iceblue Classic variable customization. Iceblue, the regular Iceblue package, already contain CSS variable definitions. So this is not limited to just Iceblue-REM. Iceblue-REM comes with the additional pre-built REM selectors. It also comes with some customization on ZK components to make them more scalable by default without further customization. But you can already use the CSS variable approach to control your components even in a regular Iceblue project. So let's take a comparison between the two. I'm going to go and show you the last sample for today, which is a modified page where we declare a few things. We have our font size and our ZK-REM selectors, variables pre-built here. Those are going to work in your Iceblue-REM package. They are not available in regular Iceblue. However, what is available in regular Iceblue is that in our recent release, we've introduced variable-based approaches for quite a lot of property that you may want to control directly in the browser or directly in CSS. So for example, mesh title color, mesh title border color, and mesh title background color are all properties that you can access as CSS variables. And if you redefine them, well, let's take a quick look. Let's go into our sample pages here. Sample applications. There we go. All right, so here we have two use cases. You see that on the left, we have the Iceblue theme package. And with the Iceblue theme package, the regular one, you can see that that sizing is not available in the regular theme. But with the Iceblue-REM, you can benefit from those pre-built REM controls to quickly set a relative size on your object. What is available in both cases is that our color palette for ZK component is now in modern Iceblue already available on the form of variables that are declared on the HTML element. So let's take a quick look. You can see a lot of different things you can customize here. I'm not going to go and tell you what each of them are doing. The names are pretty explanatory, and you can always click on an object and inspect it in order to see what is applied to that object. So you can see, for example, here on list footer, we have the ZK text color light being applied to it. And in the same way that on the header here, we are applying colors for the headers that are inherited from the color palette that we have written in our style sheet. So to go back to the code, you can see, for example, our mesh title background color here. The mesh title background color is being received by the variable and consumed from the value that we've edited here. If we change that value, if we pick another color, we have a quick and useful way to change any part of the UI from a central location. And those variables can be changed. You can reference a variable in a variable. So your, for example, your primary color, if you're modifying the primary theme color, can be applied to every element of the page at once. And if we want to simply add a new variable that we want to change, you remember that the footer is based on text color light. We can simply change that value to a different value. Sorry, hash sign. And there you go. The text color can be easily updated with all of the different colors that you may want from your variable. If you want to update the background as well, you just go identify where is your background coming from. So in this case, your list footer background is coming from mesh foot background color. And you can just add that color to the color that you declare. And you'll get very simply all of the elements consuming that color. All of the elements consuming that color now apply the color that you have selected. All right. From a code point of view, I think we've discussed everything important for today. So I'm going to just point you to a few interesting reads if you'd like to know more. We have an Iceblue-REM Smalltalk. You can find it into our Smalltalk section. We have a Iceblue-REM branch on the sim template repository. That's our public sim template. You can simply check out that branch, build your own, or modify it directly there. And all of the sample used in that presentation are available on GitHub into our Zcos demo projects. You also have the links here. All right. That's it for that presentation on the basics of REM units and CSS variables in ZK, what they are used for, REM scaling, as we discussed, great for building a UI that stay consistent with itself, even if you change the base unit of the page. CSS variables, very useful to factorize your CSS code. Um, and to update them from a single point. Okay, I see we have a question. Can you find a list of all of the CSS variables somewhere, or is it enough to simply check them on the root element of the page? Yes, on both. So if you look at the root element of the page, you can just read the list of CSS variable. If you go to the GitHub page for the Iceblue theme, so either Iceblue or Iceblue-REM in this case, but you will have more in the Iceblue-REM. You will be able to simply look at the profile page. Profile compact and profile default are the things that you want. They have a little bit more comments on them, so if you want a little bit of reading help, this is better than simply looking at the body of the page. I'll just drop it for you in the chat if you want to go there. But it is in the same repository that I linked in the presentation for today. You can just find all of those CSS variable here. And if you want to know where they're consumed, you can simply have a quick look at the comments. The variable name should also be fairly accurate as to what it does. And you can also simply just search it into the repository. If you clone it, you can use your local product. You can use your local IDE project tools to do a search on your project. If you use it on GitHub, you can use GitHub search, which is a little bit fiddly, but it works. If you're familiar with it, that's fine enough. Okay, I hope that covers it. Do we have any other question? Anything you'd like me to go into further details? If not, I might do maybe 2 extra minutes on just a little bit of performance talk about what you should and shouldn't do with those variables. And after that, I think that's going to be it for today. All right. So I'm not seeing any more question at the moment. I'll just mention it quickly. Variable resolution in CSS, as I mentioned earlier, is occurring at runtime. Those values are not compiled into the style sheet. Your browser engine is going to read your variables, and at runtime is going to update the different places where those variables are in use. This is generally very cheap in performance cost. That's as long as you're not doing something um, uh, complicated with your CSS selectors for those variables, you're not going to introduce too much latency or too much extra processing into your page, especially if those objects are fairly static. What you want to look for is pseudo classes in CSS when you write your rules that do back search. So a good example of that, and I'll mention it. I don't have an example to show you because it's a bit out of topic for today. But if you look at the CSS has selector, the CSS has selector is a tricky one. It lets you target an element by its descendant. So usually in CSS, you would put a series of selector. So my root element, my middle element, and then my target, and then declare some rule on that target. But there are use cases where you want to declare rules on your middle element, for example, when and only when it contains that final element. So you would write it in a way that include the has pseudo element. In this case, that would be my H1 has P, a paragraph. So you're not targeting the paragraph, you're not targeting the child, you're targeting the H1 object that contains a paragraph that has an immediate descendant of paragraph. And you apply some style to it. So what that does is it loops the searching pattern of the CSS selector from instead of going cascading from the top to the bottom, it can go up and down and up and down and up and down. Those searches can become expensive, especially if you're going to train multiple of them. The complexity of that search can become quite high. And in this case, when you change a CSS variable inside of one of those rules, you're going to trigger those rules every time the CSS variable changes. So it's not exactly what you expect out of the box or the default use case. My warning for you today, if you're doing some heavy CSS, is beware of has and of other CSS functions that causes um, non-linear element resolution, essentially. And that's a concern that even the MDN page is aware of. If you go at the end of this page, you'll see that it has a performance consideration that goes into a lot more detail on on that topic. If you're using the has class, I do recommend that you go into further reading on that one. All right. So if you want to simplify all of what I've said, no performance concern if you're using it in the out-of-the-box way or not doing some very complicated CSS rule, especially CSS rule with pseudo elements, such as this one. And if you're doing that kind of complicated CSS chaining, I'm sure that you know already enough about CSS that you'll be able to make sure that the complexity doesn't go overboard. All right. Okay. Do we have any other, let's see. Is it possible to have alternative background color in a list box every other line? Yes, it's absolutely possible. There's even a built-in row odd, I believe is how it's called. So let me go and take a look. We have our list box here in our application. I'm going to go to our application here. And we're going to take a look at the list box. So I'm going to close the list header, and I'm going to go to the list item. What you're going to see in that is we have a class that ZK applies automatically to every other line of your list box. Not just list box, every mesh element. So that's going to be your list box, your tree, your grid. And that list box odd can be used to give a separate styling to your class. So if you take a look at what's defined by default, in Iceblue, we're not defining a value here, I don't believe, but no one is stopping you from simply adding one. And there was one by default in older version of Sims. So on the previous, sorry, we're not defining a variable, we're defining a CSS class. So I'm just going to add listbox odd. I'm going to add a background. You can put background color, background image, background, whatever makes sense for you. And so for this one, we're going to go for, let's say something fairly light. Let's make it DDEEDD to make a light gray that is visually useful. This might be a little too light. Yeah, it's a little too light. So you'd want to make it slightly less light to be visible. So let me just change it here. Let's go with AACCAA, maybe something like that. And okay, background is applied, but we're not seeing it. Why is background not visible? Because we have, yes, because we have actually already, my bad. We do actually have something by default. So you're going to see the live process of me figuring out my own code. If you look at the list cell inside of the list box, oh, that's where it is. We have the background here that comes with the mesh stripe background color, which it is already a CSS variable. Even more useful, you don't need to define your own class. You just need to make a change to the mesh background color. By default, the mesh background color is the same uh, as the is the same for both the odd row and the non-odd row. We could change it here as a variable, but it's going to change everything. So instead of changing everything, we can just redefine that CSS class. So we're going to go and get ourselves this entire CSS rule. We're going into our code. This is what is applied by default. Instead of the mesh stripe background color, we can either put our own direct value here. So I've started with DDCCDD, I believe, earlier. If we refresh that, now we can see that we have striping every other row. And if we want to use one of the variables that are provided by your theme, so remember that just a few minutes ago, we were talking about the color palette here. We could put it a color primary lighter, which is a color defined by your primary color. So we're going to use that built-in variable instead. We're going to go and put in var for the variable CSS function and the ZK color primary lighter. So the light version of the primary color for the theme. And there you go, direct striping from the CSS variable. There you go. You can apply the same behaviors also on, as I said, on grids, on trees. All of those have the ability to use the row odd. Let's see. A bit off topic, but it would be nice to propose a dark mode switch for Iceblue theme. Yeah, I don't believe we have one that is built in the same theme, but we do have a theme pack that has quite a lot of options you can choose from. Let me go to the ZK theme pack. This one is available if you have access to the ZK repository, and it contains quite a lot of built-in variations on the Iceblue theme. They're the same theme with different palette, some of them with extra feature for accessibility. If you have a requirement for the accessibility patterns, high contrast type of thing. But if you'd like to see what is essentially a dark theme variation on Iceblue. Montana is not bad. Emerald, if you like a little bit more color. And if you want something that is already built in with WCAG accessibility control, those are not dark, but they are high contrast. I know it's out of the question you were asking, but they're quite useful if you want to implement a strong visual contrast for your elements to help with readability. Oh, oh. Sorry about that. All right. I think that covers the question. Was there anything else you'd like to discuss? We still have, let's say, 5 minutes before I'll have to wrap up the training for today. For anyone that is still around, we're going to finish the Q&A. If you'd like to simply wrap for now, thank to everyone for coming. I hope this was both interesting. If you were already familiar with those concepts, I hope that the ZK section part of the presentation was helpful in figuring out how they apply into a modern ZK sim. And if you were not already familiar with those, I hope that was helpful in getting an idea of the useful new tools you can apply to your ZK applications. All right. I'm not seeing any other question at the moment, so I'm going to call it for today. Thank you everyone for coming and have a good day.